All right, hello, my name is Brandon Clayton, the Algebra Guy, and today I want to talk to you about opposites and opposite notation. So we're going to get into a discussion that involves, as you can see, opposites and even integers, but let's go ahead and jump right into it. Let me get my handy drawing tool out, and let's do it. All right, today I want to answer the following questions. What is meant? What is meant for numbers to be opposite? And what is opposite notation? And lastly, what are integers? What are integers? All right, so what is meant by numbers to be opposite? So let's look at this number line. Well, as we attempt to answer that question, you'll see that it's pretty intuitive. There's nothing deep, but it's a great foundation in which to build on. So if I think about numbers that are opposite, let's take 2 for an instance. So we start at 0 until, I'm sorry, -2. We start at 0 and we go back 2 values. But what's the opposite of -2? Well, the opposite of -2 is 2. And that makes sense, right? You see 2 in both of them. But the understanding I want to make sure you get is that both of these values are 2 units away from 0. So 2 units to the left and 2 units to the right. And that's why they are opposite. So the opposite of a number is the number that is the same distance from 0 on the number line, but on the opposite side of 0. So it didn't have to be on the left or right, just on the opposite side. So if we looked at another example, you'll see the same thing with 3. We start at -3. The opposite of -3 is 3. And I could have went vice versa too, right? I could have started with 3 and went to -3. Those are opposite of each other. So it's pretty straightforward, intuitive. Find the opposite of -7. First, you're going to draw a number line just to get the concept of it. And I went ahead and sketched one out for you. But you get the idea, hopefully, at this point. 7 is 7 units from 0 so to the right. So where would I find the opposite of 7? That's obviously going to be right here to the left of 7. And the same thing for -10. If I started with a -10 over here, then 10 units to the right of that, instead of -10, we're going to have a +10. So those are opposites. So what about opposite notation? All right, so you've seen this symbol before, this little / sign in 3 different ways. So let's talk about those 3 ways. You've already seen it. But when we talk about opposite notation, that's often the symbol that we're discussing. This little dash will mean something opposite. So here's one way, 10 - 4. So in other words, between 2 numbers, the symbol indicates the operation of subtraction. We read it 10 - 4. 10 - 4 is 10 - 4. So it could be used this way to talk about the opposite, or that sign could be used this way, 10 - 4. -8. In front of a number, the symbol indicates a negative number. We read this -8 as -8. So that's 2 different ways so far. And what about -x? In front of a variable or a number, it indicates the opposite of some value. So we read this -x as the opposite of x. So whatever x was previously is going to be the opposite. And lastly, we have negative or minus -2 or -2. Here we have 2 signs. The sign is in the parentheses indicates that the number is -2. The sign outside the parentheses indicates the opposite. The opposite, what did I write there? We read -2 as the opposite of -2. Let's practice, make sure we got it. So if those things are true, what would this be? What would the opposite of here? So if we're thinking through this, so that means we have -6. And this is telling us to do the opposite of a -6. So the opposite of a -6 is going to be, well, +6. You know, we just talked about what's the opposite. We looked at the number line. We did a 0, and we said, well, if the original was -6 right here, well, the opposite of that is going to be a 6, +6. Another way to think about this mathematically is you have a negative and a negative. So whenever you have parentheses and 2 values next to each other, you're going to think of it as something times another thing. So this would be negative times negative, which we learn also is equal to a positive value. So that's another way of looking at it later down the road. Continuing this discussion, the opposite of a -1 Again, if you were to think of it in a number line, you can realize that -1's here. So here's my -1. Well, what's the opposite of whatever's in this parentheses? Opposite of a -1, well, it's just going to be 1. So this is just 1. And you've probably seen the pattern by now, so you know the opposite of a -5 is 5. All right, what are integers? So this easily leads into the answer. What is an integer? So integers are counting numbers, their opposites, and zeros. What are your counting numbers? Counting numbers are just 1, 2, 3. You know what? Actually, I should do it in that same color. That'd be cute, wouldn't it? So let's do 1, 2, 3. We'll do their opposites, -1, 2, 3. And we'll do a 0. So, I didn't change all those numbers. Oh, yeah, I did. Yellow, orange, and red. So that's all integers. So, and obviously this keeps on going on forever in all directions. So those are all integers. Now we're not counting decimals when we talk about integers. We'll talk about that later. But for right now, integers are just those counting numbers, 1, 2, 3. The opposite of counting numbers, which is 1, 2, 3, 4, 5, 6, and so on, and include the 0 in between. So let's practice and see if we understand everything we just talked about concerning integers and opposites. Let's look at this. Evaluate -x when x equals 8. So let's call this problem A. Let's say this is problem A. So we want to know, what is -x going to equal if x was 8? So let's rewrite this as -x. So we know that x is equal to 8. So this negative still is going to stay here. We're just going to replace the x with 8. So we can now see that it's going to equal -8. Because it's the opposite of whatever my x was, and my x was 8, or is 8, so the value is going to be -8. What happens if you have x equals -8? Well, I think you're catching on pretty quick, and you'll realize that -x is what we're evaluating. So what if we would have put, what did I put? A. Let's call this part B. Let's call this part B. So what if we got a negative here, now we put a -8 in place of x. So we put a -8 right here, a -8 right here, and now we end up with a negative times a -8, or the opposite of -8, which is equal to 8. Let's do a couple more, or at least one more actually. I think that's what I have. So -n. What if I put a 4 there? What does it equal? So it originally was a -n, so the opposite of whatever my n is. So n is equal to 4. So what's the opposite of a 4? Well, that'd be a -4. So this will equal -4. And when I evaluate, when I put the 4 in place of n. So what if I put a -4 there? This would be a negative n is what we're evaluating, -4. Because I put this whole thing in place of this n right here, and now it gave me -4, which tells me that's going to be the opposite of a negative, which is a positive. And that's it. Do we accomplish our goal? We checked those off pretty quickly. What does it mean? What is it meant for numbers to be opposite? Check. We talked about it's the same distance from 0. What's the opposite notation? We got this little symbol here we call negative or minus, or there's probably other names you can use, negate and so forth. What are integers? Well, integers are all the counting numbers, 1, 2, 3, 4, and their opposites, -1, 2, 3, 4, -1, -2, -3, -4, and 0 included. So we've answered all those questions, and thank you for tuning in. Brandon Clayton here, The Algebra Guy, and I'll see you next lesson.